This is example 5.4.22. Here we are given a constant coefficient difference equation, and we're asked to find the transfer function h of z as well as the impulse response h of n. To find the transfer function, what we do is we take the z transform of this equation over here on the left as well as on the right. When we do that, we will reduce it into this form. Z transform of y of n is y of z. Z transform of this is simply the coefficient 4/3. And since y of n is delayed by 1, we get z minus 1 y of z. This is again the same. This is y of n minus 2, therefore we get z minus 2 for y of z, and so on and so forth. Similarly, for x of n and x of n, z transform is x of z. Z transform of x of n minus 3 is z minus 3 x of z. So we collect the y of z on one side and x of z on the other side. Remember that the definition of transfer function is y of z over x of z. So we just collect the polynomials for the numerator as well as the denominator, and this is the transfer function in the negative power of z. If we want it to be positive powers, we simply multiply by the highest power of the numerator or the denominator. In this case, they're equal. So we can get z cubed minus 1 divided by z cubed minus 4/3 z squared plus 7/12 z1 minus 1/12. So this is in the positive power of z, or this is in the negative power of z. They are the same h of z. Notice that the order of the numerator and the order of the denominator are the same. So this is an improper rational function. And remember that for partial fractions, we need it to change it into a proper fraction. So we can get it from by long division. Okay, so how do we do long division? Let's try. We will divide this polynomial with this polynomial. We will write it in negative power of z. So it is minus z3 plus 0z minus 2 plus 0z minus 1 plus 1 to represent the numerator, dividing it by the denominator. In the denominator, we are writing it in power of z from the negative power first. So negative 12 z minus 3 plus 7/12 z minus 2 minus 4/3 z minus 1 plus 1. So we are trying to divide this term with this term over here, which is the denominator. We are writing it backwards because we are putting the highest power, the negative highest power in front. So the first term that we should multiply with is to get this power and this power to be the same. This is minus. So we are going to multiply by 12. 12 multiplied by this polynomial is, so when we select 12 and we multiply with this polynomial, we get the polynomial below. We choose 12 so that the first term minus z minus 3, and here is minus minus become plus, z minus 3 will become 0. So we remove the highest order, negative order power. So what we do now, so after subtracting, we have this, and this now is a lower power than this polynomial in the denominator. So what we can do is we can write it in this way. It will be equals to, this function is now equals to 12 plus minus 11 plus 16z minus 1 minus 7z minus 2 divided by 1 minus 4 over 3z minus 1 plus 7 over 12 z minus 2 minus 1 over 12 z minus 3. So this is this equation over here, where this term is P of Z. So again, the trick is first to recognize that we have a improper rational function. We use long division to get it into this form. Some functions of polynomial of z, in this case is about 0, and the proper rational function. We are now ready to perform inverse z transform to get h of n. So let's copy this equation here to the next page. Now the next page shows us how to find the p of z, because 12 is already taken care of. It is very error prone because we are now in a third order of polynomials. So you're better off using residual z with the coefficients of the numerator and the denominator, and this is what we find. So we are going to write down the equations now. H of z is equals to k is 12 plus 114, which is the R1, over 1 minus half. Half is this, z minus 1. The important thing to note is that we have repeated pole, which causes us a lot of problems because you will see this. So never mind, we'll copy down minus 21 first from here. On the left hand side, minus 21 goes to here. The 0.5, which is the second one, goes to here. But we are repeated pole, so the whole denominator is to the power of 2. And the last one is minus 104, goes to the third term here, plus minus 104 divided by, and in this case we have a new pole, so it is 1 minus 1/3 z minus 1. So you compare and you see that this is how we get this equation. This is of course P of z, and this 12 was what we have on the top. So we are almost ready to perform inverse z transform. Inverse z transform, 12 becomes 12 delta n. This is simple. This is 114 half to the power of n, un. The third one is plus minus 21 n plus 1 un. We do not expect you to know how to do this. There's no lookup table for this, but you can check it by yourself later on with the lookup table. And in the last one is plus minus 104 1/3 n un. So you'll see that this is how we get h of n from h of z. We can then plot, and you can see that this is the impulse response across time, and it dies basically after possibly of n greater than 20. Notice that the values are not 0, it is just very small and we can't see it, that's all. So in summary, to perform this question, what we did was we take the z transform of a difference equation to find the transfer function. We find that the transfer function is improper. We use long division to find the coefficients, to make the equations into proper form, which is 12 plus this pz, which is a proper rational function. We use pz and we perform partial fraction to get it into this form, in which we can use inversely transform table to do it term by term. Finally, we can get the answer over here of Hn, and then we can plot. So this ends our discussion for this example 2. Thank you.